morning, everyone. I wanted to go ahead and try to touch on some of the properties of parallelograms. And so I'm just going to go over a couple of these problems. I want you guys to try them and do the vocabulary on the back. And then tomorrow we will discuss it, okay? Again, I can't grade something that you don't do, so I need you to complete it to the best of your ability. So let's look at the first four problems. Most of these things you already know. Like, for example, in a parallelogram, the opposite sides are equal. So, like, for example, on this first one, they ask for BC. We know that that's going to be 16.4 because the bottom of the parallelogram is 16.4, right? So that's pretty easy. All they're doing on numbers 3 and 4 is putting in algebraic expressions, right? So like if I wanted to find the value of x in order to find the length of KL, I would have to do 3x plus 5, which would be the top of the parallelogram, equals 4x, which is the bottom of the parallelogram. And then of course I would have a little bit of algebra to do in order to solve that. Okay, so that's how you're going to do numbers 3 and 4. You're going to set them equal and solve it. I'm going to go ahead and finish that one really quickly. So I would subtract 3x from both sides. And that would give me, I'm going to run out of room here, 5 equals x. So x is 5. So if x is 5 and I need to find the length of KL, that means I would just put 5 in for this value here. So 3 times 5 plus 5 would be 20. So that would be the answer to number 4. So I'm going to let you try the other one. As far as angles go, they're also pretty straightforward. So 5 through 8 deal with the properties of angles and parallelograms. Opposite angles are equal. So that's pretty straightforward. You have two obtuse angles, two acute angles. They're equal to each other. It's the adjacent angles are supplementary. That's the other property. So for example, if I needed to find angle Z in this diagram, I would have to do 180 minus 112. And what's that? 68? That's 68. Okay, so remember that opposite angles are equal and consecutive angles are supplementary. So again, you're going to use the same concept on number 7 and 8. There just happens to be a little bit of algebra in it. Now, I would not suggest that you use the opposite angles are equal in this one, because if you notice, the opposite angles have different variables. One has an x and one has a y. And unless you want to do some upper algebra, I suggest sticking to the adjacent angles are supplementary. For example, if I wanted to find angle A for number 7, I know that angle A and angle B are supplementary, and they both have a y value in them, so that's going to be easy to solve. So all I would do is 2y plus 4y equals 180, right? So add the two angles, they're supplementary. Of course, 4 and 2 is 6, so 6y is 180, which would make y equal to, what, 30 degrees, or 30, not 30 degrees. Okay, so if the value of y is 30 and I'm looking for angle A is 2 times y, so that means A would be 60 degrees. Okay, so you're going to do something very similar to find angle D for number 8. Then we move on to the properties of the diagonals. I mentioned the other day there are a lot of diagonals and quadrilaterals that we deal with. The only property for the diagonals of a parallelogram is that they bisect each other. They're not congruent, but they bisect each other. Both of them are bisected, not just one like what happened with a kite. The picture for 9 and 10 is kind of weird. They're just showing you that full length from F to D is 20. That was the point of that extra little thing they put there on the outside. So if they're bisected, like we know from H to G is 14, so E to H would also be 14. So if I wanted to find the entire length, of course I would have to add and get 28. Now 11 and 12, I am not going to ask you to do these two. Do not worry about doing numbers 11 and 12. The reason why is because you do have to know how to do some Algebra 1 for this problem, and obviously you have not yet taken Algebra 1. Now the concept, of course, is that the two pieces are equal, but kind of like I mentioned on the last up there on number 7 and 8, you're going to end up with two variables in one equation, and we just haven't learned that yet. So do not worry about doing numbers 11 and 12. Okay, let's look down at number 13. A proof. I know everybody's excited. I'm going to leave number 1. I would like for you to fill that out. And I'm going to leave number 4 because I feel like you should know what goes in those two places. Now, as far as the other two places, let's look at the information that's given. Of course, here they're giving me a parallelogram, and then we're trying to prove the two triangles are congruent to each other. So number 2, I don't have a statement, but it says the reason is the diagonals of the parallelogram bisect each other. So all I'm going to do is name the pieces that are congruent because they're bisected. So that would be something like EK is congruent to KG. Those two pieces are congruent because that is being cut in half. And then I can do the same thing for the other diagonal. HK is congruent to KF. Okay, so that would be my statement for number 2 because that's what happens whenever you have the diagonals and they bisect each other. Then let's look at the statement for number 3. Number 3 says EF is congruent to GH. Well, those are just two sides of the parallelogram, and that is one of the properties, is that the opposite sides of the parallelogram are congruent. So that's actually the reason for number 3, and I'm going to abbreviate here, is that the opposite sides of a parallelogram are congruent. Okay, and so that's a pretty straightforward proof. Again, I want you to put number 1 and number 4 in there. And then finally, number 14, to be super honest, this has nothing to do with the properties of the parallelogram. If you read the problem, you're looking for the slanted side of the parallelogram, and they show that the height of the parallelogram is 22, and they give one of the opposite sides, and you're going to have to do the Pythagorean theorem on this one. If you look really carefully in the triangle, in the parallelogram, you have a right triangle, and you're just looking for the hypotenuse. We did a problem very similar to that earlier in the week, so I would like for you to try number 14, okay? All right, so again, complete this, the front and the back, and we will discuss it tomorrow. I hope your day is awesome.